Hey, welcome back to MechSolids FEA tutorials. So in this one, we're going to cover single shear and double shear and the differences between the stress and stuff in each of them and how to set each of them up in a Solidworks simulation. So to start, we're just going to make our set of plates that we're going to pull apart. So the main thing here is just you want two plates, two or three plates where you're going to have a hole or as many as you want, but they just need to have their centers line up. So I am just gonna quickly make a plate. Like so. Okay, cool. So now we've got a plate. So I'm gonna save this and call this shear plate. Okay, so this is the plate that we're going to use to create shear, single shear and double shear SolidWorks simulations. So go over to SolidWorks simulation tab. Actually, sorry. So you're going to hit File and then Make Assembly from Part. Okay, I'm going to choose Shear Plate. Click wherever you want. Okay. So now we're going to insert another shear plate and we're going to mate these two things together. So we're going to come up here to mate and we're going to make the first mate we're going to make is a coincident mate. We're going to choose the bottom face of this top one and the top face of this bottom one. That will kind of slap the two things together, like so. Okay. Next, we're gonna make a concentric mate, and that basically means that the centers of two circles are in the same spot. So I'm gonna choose this one, and then this one, and this one. And it will rotate around so that we've got this set up here. And you can see how we're gonna put some bolts through here, fix this end, and pull this end. And that is the essence of a single shear. So we're going to go over to SolidWorks simulation, make a new study. We're going to call this one single shear. Okay. So for all of this, we're going to set the material. I'm just going to call this 6061 aluminum. Okay. So first things first, unlike the previous couple tutorials where I've said we're going to run left to right, this one we're going to start with the connections. So we're going to create a bolt. And this bolt, there's lots of different types of bolts. You can also choose a bunch of different types of connections. So there's countersinks, like all this good stuff. We're just going to use a standard bolt. Okay, so the first one is going to be the circular edge of the bolt head hole. So that's just going to be, we want the top of the bolt to go here, so we're going to click that circle. Next one is the circular edge of the the bolt nut hole. Okay, and we're just going to choose the bottom, and you can see our bolt is going to run through here. Okay, so for the connection type, this is going to be, we're going to choose distributed because this is more realistic. So this means the bolt is going to kind of bend a little bit, whereas with rigid, it assumes that it does not bend. Okay, so for the material, it defaults to alloy steel with these Young's modulus and Poisson ratio values. And we're going to leave that for now because that's generally pretty good. For strength data, you can put in the stats of your bolt, like say we're using a 10 threads per inch bolt with a PSI of like 75,000 or so. Okay, and we're gonna put in our go-to set safety factor. Okay, we're gonna leave preload alone for now because we don't need that for this tutorial. Okay, so before I hit check, I'm gonna pin this and then hit check. Okay, we're going to now do the same thing with the other hole. Okay, click the top of the bolt, the bottom, and then all this is gonna be the same. Okay, sick. Now we've got our 2 bolts. Okay, next we're gonna set up our local interactions between these 2 plates. So I'm going to show you a trick to automatically generate local interactions. So we're going to hit local interaction and we're going to do automatically find local interactions. Okay, and it's going to ask for the parts that you want, and we're just going to choose our 2 shear plates here. Okay, and then we're going to hit find local interactions. Okay, and then we're going to hit check. And it's going to say, do you want to create selected local interactions? And yes, we do. Okay. Next, we are going to fix this edge, sorry, this face, and we're going to add a force to this face. So we can go fix geometry here, check, add a force, and we're going to say maybe like 3,000 pounds or so, or maybe 2,500. Let's just play safe. Okay. Cool. So now we are ready to make our mesh. So we're going to go under run to study, hit the caret, hit create mesh, and for this one, I mentioned in the last tutorial that the higher the mesh density, the more accurate it will be. However, with this one, you will see a little bit extra runtime. So as you increase the mesh density, it's going to take longer and longer. So for this, we can leave it somewhere in the middle. Hit check. Okay, our mesh looks good, and we can hit run study. And so it's just warning that we set the preload to 0, and that's fine for now. Yep, so as you can see, this simulation takes a little bit longer than the previous ones, but it is not that bad. Yeah, there we go. Okay, cool. So I'm gonna leave this for now, and we're gonna come back to this. So I'm just gonna save this real quick. I'm just gonna hit no for now. Okay. Now I'm gonna go back to our shear plate, and we're gonna make a new assembly from this part. Okay. Actually, we're gonna start by adding our old assembly here. Okay, and then we're just gonna insert one more shear plate, and we're just gonna slap that on top. So if you remember from the previous one, I encourage you to do this by yourself, or try it by yourself. So we're gonna have a coincident mate between these 2. Okay, and then a concentric mate between some of these holes here. There we go. Okay, so you can see we've got our double shear setup here. Okay, so now we're going to go over to simulation, new study. I'm going to kind of breeze by this just so we can get to the good stuff of comparing the 2. So we're going to choose all our parts. We are going to set them to aluminum, 6061. Okay. Let's see, we're going to create our bolts. Scroll down, assume it's steel. That's completely fine. As for our strength data, we're going to have 10 threads per inch and a bolt strength of 75,000 psi. Factor of safety of 2, and for now, just no preload. That's fine. Okay, I'm going to pin it and hit check. Oh, geez. Oh, excuse. There we go. Okay, we're just going to do the same thing now. Choose your 2 bolt heads, and everything here, oops, will be the same. Okay, so I'm going to hit check, and then X. Okay, got our 2 bolts now. Next, we're going to go over to local interaction, and we're going to automatically generate them from our 3 parts here. Okay, find local interactions. You can see it's highlighting them. Yeah, so we'll have 2 local interactions between this plate and this plate, and then this plate and this plate. Okay, that's good. We can hit check. I want to create them. Yep. Okay. And we are good to set up the fixtures and forces. So I'm going to create fixed geometry here and here. And then I'm going to pull on this end with, we'll say the same force actually, so we can compare them. 2500. Okay, check. We're going to create the mesh. Okay, everything looks good. We can hit run this study. Again, it's going to warn us about the preload thing, but that's fine for now. Okay, so now we have our 2 our 2 FEA models. So what I like to do is come in here to chart options and hit show min and max. Okay, just gonna hit save real quick. I'm gonna go over to our other one, go down to our single shear study, double click stress 1 to look at the stress, double click it again to go to chart options and hit show min and max. Okay, so we can see here that the max stress on the single shear is about 4.7 e to the 8 times 10 to the 8 newtons per meter square. Okay, and if we come over here to this one, we can see that our max stress is only 1.2 times 10 to the 8. So you can see that max stress it decreases with double shear. Yeah, so we can also come over here to look at displacement. You can see our max displacement here is about 0.3 millimeters, whereas with our single shear, our max displacement is 2.5 millimeters, which is significantly more. So yeah, that's the main differences between a single shear and a double shear joint, and how you model both of them in Solidworks.